Hi everyone. In this video, we are just going to be doing some basic derivative word problems that uses the power rule, product rule, chain rule, and quotient rule. So we're just going to hop straight into it here, starting with this word problem. The height h of t of a piranha plant in centimeters is modeled by the function 5t cubed minus 3t squared plus 8, where t is the time in weeks. Find the rate at which the piranha plant's height is changing at t equals 3 weeks. So what we already know is that we're given a function h of t, which is 5t cubed minus 3t squared plus 8, and we need to find the derivative of this function. We can take the derivative of each term, starting with 5t cubed. Taking the derivative of that term would get us 15t squared. Doing the next term, that would get us 6t, and the derivative of 8 is 0 since it's a constant. Okay, we found the derivative of the function. Now what we need to do is we gotta plug 3 in. Doing so, this gets us 15 times 3 squared minus 6 times 9. Oh wait, not 9, what the hell? 3. 6 times 3. Sorry about that. This would be 15 times 9 minus 18. Then we want to multiply 15 and 9, which should get us 135 minus 18. And doing the math here, we would get 117 centimeters. So the rate at which the piranha plant's height is changing at t equals 3 weeks is 117 centimeters. So this problem wasn't too hard, and I don't think the further problems would be too hard as well. So let's keep going. Let's do a product rule problem now. The velocity, v of t, of a Cybertruck, aka the not so great financial decisions vehicle, in meters per second is modeled by the function v of t equals 2t plus 1 times t squared minus 3, where t is the time in seconds. Find the Cybertruck's acceleration, aka rate of change of velocity, at t equals 4 seconds. Okay, so what we could do here is we could label the first part of the function 2t plus 1 as our f of t. I'm going to do it right here. We could label that as 2t plus 1. And we could do the same for g of t, which would just be, sorry about that, t squared minus 3. And we want to take the derivatives of each of these functions so we could plug them in to the product rule formula. Doing this with f prime of t, it would just get us 2. Derivative of 1 is 0. Doing the same for g prime of t, deriving this would get us 2t. Now we could plug this in to our product rule formula, v prime of t. This would equal 2 times t squared minus 3 plus 2t plus 1 times 2t. Okay, we could do distributive property here. Doing so, this gets us 2t squared minus 6. I'll put this in parentheses. And we want to do the same for the right side. Working with the right side, 2t times 2t would just be 4t squared. And 2t times 1 would just be 2t. Now we can combine like terms, starting with the terms with t squared, which is 2t squared, and 4t squared, which would add up to 6t squared. And we only have one term with t, which is 2t, and one constant, which is -6. So 6t squared plus 2t minus 6 would be the derivative of v of t. I'm going to erase some of this so we could do the last part of the problem. We can now plug in 4 into v prime of t, which would be v prime of 4. And plugging 4 in, we would get 6 times 4 squared plus 2 times 4 minus 6. Now this ultimately comes down to doing some math. 4 squared is 16, and 16 times 6, 96. 2 times 4, 8, minus 6. And doing the math here, this would get us 98 meters per second. So the Cybertruck's acceleration at t equals 4 seconds is 98 meters per second. So without any further ado, let's move on to the chain rule problem. The volume of a cube v of x is related to its side length x in centimeters by the formula v of x equals 2x plus 3 cubed. Find the rate at which the volume is increasing when x equals 2 centimeters. Feel free to pause the video and attempt this yourself. What do we notice about this problem? We notice the formula v of x equals 2x plus 3 cubed. And what we could do is we could apply both power rule and chain rule. And doing so, this gets us 3 times 2x plus 3 squared times 2. Okay, and what we could do next is we could multiply 3 and 2 together. And doing so, this would get us 6 times 2x plus 3 squared. And this will be the derivative of v of x. Finally, with this step, we want to plug in 2, v prime of 2. And doing so, this will be 6 times 2 times 2 plus 3 squared. Okay. And doing the math on the inside, 2 times 2, 4, 4 plus 3, 7, and 7 squared, 49. This would equal 6 times 49. And I'm getting out a calculator for this one. And 6 times 49 would just equal 294 centimeters. So the rate at which the volume is increasing when x equals 2 centimeters is 294 centimeters. So without any further ado, let's move on to the last problem, which is the quotient rule. Let's work through one last problem here. The intensity I of d of a light from a lamp decreases with distance and is given by I of d equals 50 over d squared plus 1, where d is the distance from the lamp in meters. Find the rate of change of light intensity when d equals 5 meters. Feel free to pause the video and attempt this yourself. Okay, so what we could do here is, I'm going to do this right here. We could write out f of d, and this would just be equal to the numerator, which is 50. G of d will be equal to d squared plus 1. And deriving these functions, f prime of d would just equal 0 since it's a constant. G prime of d would just equal 2d. Okay, and now writing this out in the quotient rule formula, this would be equal to 0 times d squared plus 1 minus 50 times 2d. And this will all be over g of d squared. And we could just write it as d squared plus 1 squared. Okay, we would now need to perform math in the numerator. And doing so, 0 times d squared plus 1, that would equal 0. And 50 times 2d, 100d, and we have a negative sign. So I'm just going to write out negative 100d over d squared plus 1 squared. And this will be the derivative of I of d. Finally, we could plug in 5 into I prime of d, I prime of 5, and this would equate to negative 100 times 5 over 5 squared plus 1 squared. Okay, negative 100 times 5, negative 500. 5 squared, 25, plus 1, 26, and 26 squared. Okay, I'm going to get out a calculator for this one. 26 squared would be 676. This fraction can be simplified further by dragging out 4 from the numerator and the denominator, since that is the greatest common factor of the two. And doing so, this gets us negative 125 over 169. And this will be our final answer. The rate of change of light intensity when d equals 5 meters is negative 125 over 169 units per meter. Okay, that's going to be all for this video. I really hope you enjoyed it or learned something from it, and if you did, feel free to like, subscribe, and hit that bell, and please leave feedback in the comments section, whether it's positive or constructive, for future improvement. That's going to be all from me, and I will see you in the next one.